Hey guys, in this tutorial, we're going to look at the bridge between FlowCanvas and NodeCanvas. So we're going to look at how to seamlessly stitch both plugins together so that we can use the best of both worlds. We're going to be able to embed FlowScripts inside finite state machines, inside behavior trees and dialog trees, no problem, as well as the other way around. We're also going to be able to make use of some features that are available in NodeCanvas, but traditionally are not available in FlowCanvas, but are made available by the bridge. So the first thing we want to do is we want to download the bridge, which is going to bridge the gap between FlowCanvas and NodeCanvas. So you can find this here, NodeCanvas to FlowCanvas bridge. That's in the FlowCanvas downloads. You can also find it in the NodeCanvas download section. We're just going to download that. So once it's downloaded, we're going to double click that Unity package and we're going to import it. So click import, and now we have this folder here, NodeCanvas to FlowCanvas bridge, and we're ready to go. So what this lets us do is use NodeCanvas and FlowCanvas seamlessly together. So let's have a look at it, an example. So let's grab a door here and let's add a FlowScript controller. Create a new bound FlowScript controller, and here we have our canvas. So what I'm going to do first is add an event as our entry point. So go into events. In this case, I'm going to go for a UI pointer because I'm using the mouse to interact with everything. And now we can hook up when we click for it to do something. And because we have that bridge installed, I can actually use a task action like this, just like we would use in NodeCanvas. And I can connect that in like that, and I can give it a task. So for example, let's lerp that door so it opens. So we're going to use an ease tween, and we're going to choose 120 and back out. And we choose rotation here. All right, and we're going to not use our self, we're going to use this here, drag that in, there we go. And of course, we can add additional actions. So let's add another action. For example, play audio. So I'm going to play the audio at my red door, and I'm going to choose a door open sound effect. All right, so let's click that door, opens up. Now we're not really handling anything else, so if I click it again, it's basically just going to try to run that same action list over and over. And just as we have access to our task action, we also have access to task condition. I can create a switch condition and plug that in there. And now I have a nice stack of conditions that I can hook up. And I can drag this into there. So for example, let's add a variable here. A bool is open. And we want to make sure, there we go. So if it is not open, and we can add another condition. So for example, let's check the distance. Let's check a distance to the player, for instance. So less than 3. And we have all required here, just as it is in NodeCanvas. And I'm going to drag the player in there as that target. So if the player's distance is less than 3 to the door and it's not open, then it's going to do this action list. And I'm going to set here is open to be true. And so now when we look at our graph there, we're failing our condition because we're not less than 3. We get close enough, we click the door, it now opens, but the door is already open, so we're not going to pass these conditions. Now another great thing I can do is I can use a sub dialog tree. So here inside subgraphs, I can very seamlessly start a sub dialog, have it wait until it's finished, then move on out. So what I'm going to do here is I'm going to, when I click, start this dialog tree, and then when it's finished, check that condition and open that door. And so what I need to do here is create a new dialog tree. So create new, just call it dialog tree for now. And to access that dialog tree, all I need to do is double click that node. And now I'm inside there. I can say, this looks like a door. What should I do? And let's give it a multiple choice. So multiple choice here, add a choice, open the door, add a choice, leave the door alone. All right, and then here, I'm going to add a task action for open and a task action for leave the door alone. And here, what I'm going to do is add onto my graph, will open the door. And then here, I can just set that Boolean will open the door true, and the other one, set Boolean will open the door false. And now if I go out here, I don't actually have access to that. So what I can do is I can click expose this public. Then in here, I can read that out, and I'm going to read that out into this variable here. So that means that when I go into that subdialog can set up its own variables and its own controlled graph, and I can choose where I call it, which variable I want to map it to when it gets written to. And then after that, I can use this in my condition. So here, for example, check Boolean will open the door. All right, so I've simplified it a little bit. So here we're still doing the readout from the will open the door. And then inside here, we're just going to choose what should we do, open the door or leave the door alone. If we open the door, it will set the will open the door to true, otherwise it sets it to false. Then we have our switch condition here, which can check that result. And of course, we can write as many of these variables as we want and have as many branches as we want outside of this. So let's see how that works. So I go here, I click the door, and I can choose to leave the door alone. That comes out as false. If I double click into that subdialog tree, this time, when I open the door, it has gone down here. If I go back up, you see this has now been marked as true, and this has opened the door successfully. So since this subdialog node is actually on the same object, it actually has access to the same Blackboard variables. So we could actually instead move this isOpen variable up here, delete it from here, and let's just reconnect it. And when I double click into here, you see I actually have access to that isOpen. And so I can just check that variable, no problem. So drag out task condition, check a Boolean, check isOpen. So we can check any of the variables that sit on this object itself. Now, of course, if we reuse this dialog on a different object, we do need to make sure we set up the same variables here. But in this case, we're only using it on this door. So if it's already open, we're just going to say the door is already open. Otherwise, we're going to do this. So we're sharing state between our NodeCanvas dialog tree and our flow graph. Now I can also add other types of NodeCanvas graphs. So for example, I can add a sub-finite state machine. So what we can do is we can use this to control our state, and then we can use this entry point here and our dialog to interact with and change our state. So just like with the sub dialog, we're going to create a new one, and we're going to call this door FSM. So now we have a door FSM, and we can double click to go into it, and now we can add states. So for example, we add a closed state, copy paste, and an open state. Then I can drag this over here, and I could add a variable to my Blackboard, open trigger. And let's create another one called closed trigger. And now what we're going to do is, instead of explicitly calling those actions like we were before, we're going to go through our state machine via these triggers. So here, from closed to open, we're going to assign a condition task, which is a Boolean trigger. So open trigger, and I'll just copy that, paste it here, and change that to be our closed trigger. And now I'm going to go back up, and I'm going to grab my action list here, copy, go into here, paste, and there we go. And as you can see, the assets cannot have scene object references, but that's okay, because we can add the references onto our object here. So our doorway, so we're going to create a game object here, door, and we'll just replace that with our variable from our red door. And then I'll copy those, paste them here, and here I'm going to set isOpen to false, set that to 0, and change the audio to door close. Just make sure we drag our door into here. And then here, instead of playing this action list, and of course we need our finite state machine to start at some point. So what I can do is I can make it start on enable. So on enable, we're going to start it And so that will be running. And what I actually want to do is I want to maybe change these conditions to, instead of checking here, to be written into some variables that we can check from any of our sub trees or our sub graphs. And so actually I'm getting rid of this from here. And what I want to do is I want to check if the player is close enough. So I will say player in range, and I'm going to set player in range to be equal to just this. And I can use an update event. So on update, we're going to write to that Boolean whether we're in range or not, and our sub finite state machine and our sub dialog will have access to that. So now we'll go back into our sub dialog and we can just use these here. So let's create a condition here, set that as the start, and I want to check if we're in range or not. So player in range. So if we're not in range, then we're going to say I'm too far away. If I'm in range, if it's already open, we're actually going to check that. So if the door is open, he's just going to say the door is already open. Otherwise, what should I do? Open the door or leave the door alone. And then here, instead of writing this, we can get rid of that. Here, we're going to finish. Whereas here, we're going to set our trigger variable, open trigger, to true. And then our Sub-FSM is going to take care of that trigger. And one more thing, I do want to pass the player in, because I want the player to be saying these lines. So I'm going to pass the player in there as the agent who's starting our sub dialog. All right, and if the door is already open, we can also give the option to close it. So I'll just drag that in there, close the door, or leave the door alone. And again, we just copy these. And if we choose to close the door, then we're going to set the close trigger to be true like that. All right, so we're playing and we can see our player is not in range. We walk closer to the door, the player is in range. Now if I click the door from here, he's going to say I'm too far away. And if we click into that sub dialog, you can see it there. And you see if we click into our sub finite state machine, you can see we're in the closed state. Now if I get close enough and I click the door, what should I do? And I can choose to open the door. So we go back into the dialog and you can see we're here. We can choose to open the door. And if I click open the door, it triggers that. And our finite state machine here has listened for that trigger. It's used it, it's turned it back off because it's a trigger, and our door has been opened like that. And if I click the door again, now because we have that shared state, it knows that it's already open, and so we're using that in our dialog, and we can close the door. We can leave the door alone. Click it again. The door's already open. What should I do? We're going to close the door. Again, we look at our finite state machine. Close the door. So by using the FlowCanvas to NodeCanvas bridge, we're able to contain all of these within one graph and have them share state instead of having many graphs all over the place communicating with each other. And we can also take advantage of using the action stacks or the condition stacks available in NodeCanvas. All right, so let's have a look at another example, this time with an NPC and a behavior tree. So I'm going to grab this guy here, and what I want him to do is I want him to patrol around, and when he sees a door that's open, he's going to close it. So what I'm going to do is I'm going to add to him a FlowScript controller, again make it bound, so it belongs to the object, and then here I'm going to use a subtree subgraph. So this is a behavior tree. And we're going to create this, and it's going to be called patrolling behavior tree. And we want to start this on enable. Our agent is going to be ourself, no problem. And again, we can go into the subtree by double clicking. And now we have access to all of the NodeCanvas behavior tree behavior. So what we'll do is we will just create a simple composite. So a sequencer with an action. And we're going to look into movement, pathfinding, patrol. All right, and we need to add patrol points. So I'm going to do that. All right, so I just have these patrol points set up. So one inside the room, one here, one here, one here, one here. And back inside his FlowScript, inside the subtree, I can create this. Now, because it's an asset, I cannot actually add these elements in here. So what I will do is I will make use of our guard blackboard again. And what I will do is just make a list of game objects and call that patrol points, and then connect that up there like that, patrol points. And we'll change it to be progressive, and speed 4 is okay. There we go. Now we've got to remember to assign these. All right, so these are all set up in here, which means I have access in here to those. So he should patrol just fine. And let's just make sure that that's working. All right, there he goes. So he's walking around to his patrol points. No problems there. Now, actually, I want to be able to talk to him while he's patrolling. Right now, I can't. But because he's on the FlowScript, it's very easy to set this up. So what I'm going to do is I'm going to add a sub dialog. So as he's patrolling, I want to be able to interrupt him. So again, subgraph, sub dialog, UI pointer. So when I click on him, he's going to start this dialog. And there we go, guard dialog. And we're going to use our self. We go in there and he's just going to say, what do you want? Now, what's going to happen is I'm going to click him and he's going to keep walking even though he's playing his dialogue, which is not great. So what I actually want to do is I want to pause the subtree while he's playing the dialogue, then resume it after we finish. So what I'll do when we start it is just plug that into there, and when we finish, plug that into there like that. All right, so what we can see here is he's doing the subtree, progressive patrol. Now, when I click him, he stops, says, what do you want? And so you see here, this tree is actually paused now. So you see here, it's paused on 32 seconds. And when this dialog finishes, which is currently on this node, he will unpause and resume playing his behavior tree. And so you can see we can control the state of the different subgraphs. All right, so the next thing we're going to do is we're going to set it up so that when he's close to the door, he's going to close it. So what we're going to do is go into our behavior tree, our patrolling behavior tree, and then here, we're going to create a variable for the door, like that. And then what we're actually going to do is we're going to use a subgraph and we're going to use a Sub-FlowScript. So it actually works the other way around as well. So we can embed our behavior tree inside a FlowScript, but we can also embed a FlowScript inside our behavior tree or inside our dialog tree or our finite state machine. And so what I'm going to do here is create a new FlowScript, which is going to be called close door. And I'm going to add a decorator onto this, which is going to be a conditional. And I've already changed this to be a selector. So it's going to select this one if this condition passes. And this condition is going to be distance. So we're going to check if our target, which is our door, is less than 5 units. And if it is, then we're going to run this Sub-FlowScript closed door. And again, we just double click and we go into it. And now you see here, we're 3 layers down. So on the 3rd layer, we have the patrolling and then we have the FlowScript. And so we can basically traverse through our different embedded trees or graphs by double clicking or clicking this here to return upwards. And so now we're inside our closed door FlowScript. And all we need to do is create an onEnable. That's going to be our entry point. And we need a finish. And so that finish can return as a success like that. And what I'm going to do is I'm going to get my character here to move to. So here we go. We're going to move to, and our destination is going to be our door. And in fact, it's actually going to be our door interaction point. So let's just rename this to door interaction point and create another one for the actual door itself. And then we'll drag that in there, get our door interaction point. We get our transform, and from our transform, we get our position. And we'll just plug that in there like that. and we'll give him a speed of maybe 6. All right, so he's going to move to there, and then what we want to do is we want to send a signal to the door to open. So here we go, create paradox notion, canvas core, signal definition, close door, and I'll put a sig for it so we know that's a signal. And we can just drag that in there like that. And because this is an asset and this is an asset, they can reference each other, no problem. All right, now remember, because we're looking at the asset, it doesn't have a reference to that door, but as soon as we press our guard and we go into it like this, that reference is there because it exists on the guard blackboard itself. And actually we are missing one part of the puzzle, which is we need to check if the door is actually open or not. Right now inside our patrolling BT, we're only checking if our distance is less than 5. So what I need to do is I need to figure out if this door is open or not. And what I can actually do is inside here, inside the FlowScript, I can use that same pattern we used before, where we use onUpdate, then task action, get other blackboard variable. We're going to select bool because it's just is open or not. It's called is open. And we're going to save that on our guard as the door is open, like that. And then we need to make sure that we set our target here to be the door, like that. So now when we look inside our sub-tree, we can easily add that condition. We're just checking this boolean if the door is open or not. If it is open, we're going to run our Sub-FlowScript, which closes the door. And inside our Sub-FlowScript, there we go, we're moving there, we're invoking this closed door. And so since we have that, we need to set that up on our door. So I click this, so we're inside our door, and we want to do a signal callback, closed door. And when we receive that, all we want to do is set our trigger to be true, because our sub-finite state machine is going to be taking care of that from our variables already. So we don't need to do anything more fancy than that. All right, and we just need to make sure we assign these. So we assign the door to the door and the interact position to the interact position. And for the door is open, this is used internally only. So I'm just going to add the underscore there to remind us about that. All right, so as you can see here, he's patrolling around. The door is not open, and so that variable is false. So let's open the door. So open the door. And now he's going to come to the patrol point. And let's just have a look in there. So he's in the subtree right now. Door is open is true. He's going to finish this patrol point here. There we go. And now, because the door is open and he's less than 5 units away, he's going to go into this Sub-FlowScript. So let's click into that. So now we're 3 levels deep. And now you see he's going to run this move to point. Then he invokes that signal, which closes the door, and now he goes back to his progressive patrol smoothly. So hopefully this tutorial helped show you how FlowCanvas and NodeCanvas can be combined seamlessly together using the provided bridge. So since everything works seamlessly together, you don't have to worry about choosing the best tool for the job. You can use them all in combination in the situation where they're required. You can switch between a finite state machine and a behavior tree as you need to. Or you can offload logic to FlowCanvas when you feel it's better to do that rather than to use task actions.